Now let's dive into trim optimization solution, which is part of Trinomic's resilient planning products. So in order to go to trim optimization, let's drill down further. And here we have all the details that we need, all the input data that we would have got. For example, customer orders, the incoming supply, what resources are available, as well as some optimization parameters. And centrally, we can look at what are the recommendations on how we should be cutting each of the jumbo rolls that are coming out of the production line, the pattern of the trim itself in order to meet the customer demand. So in this particular case, as we see here, we have customer orders for slit roll itself, or some product customer have orders as sheet. So in this particular case, we have a customer order for a width of 737 and the length of the reel somewhere in the range of 4.2 to 5.20. And the customer needs 7 pieces. And so on and so forth. We have multiple orders from different customers, as well as for sheets, we have standard A4 size, A2 size paper, and some non-standard requirement in this case. So given these are our customer orders, let's dive into what is the incoming supply. And in this particular case, we have the block schedule, which is nothing but from our planning system based on the way we have forecasted demand, how we should be campaigning to club multiple jumbo rolls together to reduce the changeover time. So these are all the incoming supplies from the process manufacturing, where we have standard jumbo reel coming in first, then the premium one, and multiple jumbo reels for standard ones again. So looking at the incoming supply, the orders that we have, let's look at the resources that are available to us. So there are two slitter and winder resource as machines, and there are two other machines which further cuts the slit roll into sheets. And what are the maximum number of knives that can be attached to each of the resource? So given the demand, given the incoming supply and the resource available to us, there are certain optimization parameters that we can set on what are the maximum number of knife changeover positions that we can have, the loss that we would like, the maximum loss that we would like to have. Based on that, the system calculates a penalty score. We can run the optimizer to look at the output, or alternatively, from one of the block schedule, incoming supply, which is for jumbo reel, we can drill down from that into looking at what are the recommendations on how we should be cutting that jumbo reel. So when we come here in the output section, we'll first see high level details and critical KPIs. So in this particular case, the jumbo reel, when cut based on the recommended pattern, it provides the details on what the net loss would be, how many knife changeover there would be, and what would be the demand lateness for all the demands where this jumbo roll would be fulfilling based on the trimmed supply. And what the system calculates is the overall penalty score. So it's a multi-objective optimizer which tries to reduce the waste, tries to minimize the knife changeover as well as the demand lateness by looking at a penalty score, which it tries to reduce by minimizing it. So let's look at what the system is recommending at a high level. So in this particular case, what the system is recommending is there are primarily two different patterns in which we would be cutting. So for all the sheets that we need to fulfill customer orders, it's recommending to have 16 rolls generated for 840 width, each consuming little more than 1% of the supply. So in all, 16 to 20% of the supply would be consumed based on the sheet customer orders. The remaining 80% of the supply would be further cut based on different knife position, which we'll shortly look in the jumbo roll detailed recommendation, where there will be 16 rolls that would be coming out in this particular case, each consuming 5% of the overall jumbo roll supply. So let's quickly drill down in this particular case. Let's see how the system is recommending. So there are 7 or 8 different knife position. In this particular case, actually 9 knife position in which we will have the knife located. So let's look at those. So we'll have one knife position here, another knife position here, and respectively many more knives that we will attach in order to cut it into different sizes. And we will do this twice, as we see here. So based on this knife position, we'll run it for 4.75 meters in length, and we'll do it twice, and then we'll change the knife over position for the next cut, which will be running again for 3 times, as we see here. And so on and so forth will continue to consume the entire jumbo roll. And this supply would then further be utilized to meet the customer demand. So let's look at which customer demand it's getting used to fulfill and how it's getting allocated. So let's go into trim. I'll clear here. So the same visualization that we were seeing, let's evaluate how it's getting allocated to different customer orders. So in this particular case, we have a customer order for 7 pieces for 737 width. And in this case, as we are going to run it 7 times, we will be having all what the supply that we need to fulfill this customer order. As well as let's look at one more demand. In this particular case, we have 500 as our width and the customer is requesting 17 pieces. So we're going to get 4 from here where we have 2 and we're going to run it twice. Similarly, 3 and we're going to run it twice. So total of 10 across the slits. And finally, we're going to get 7 out of the last one because that's where we are running it 7 times. So based on this, it has allocated which customer orders based on the trim pattern, as well as highlighted how it needs to be trimmed, the entire jumbo roll. In certain cases, like the 840, which we saw in our earlier case, will be used further for slitter operations. So let's look at one of the slitter operation. And in this particular case, the number of sheets ordered by customer is 80 for standard A4 size paper. So the 4 rolls of 840 will get consumed in order to meet the customer demand. In addition to this, we'll also have trim pattern details for instruction. So in this case, we are saying from 0 to 33.25 meters in length, which is nothing but 7 times of 475. It needs to cut in this particular pattern, and then the knife changeover will happen from 33.25 meter in length to 42.75 meter. So this is where the planners or the execution team can look into complete details of how the jumbo roll is going to get consumed in order to meet customer demand at the slit roll level or at the sheet level. And using this detail, we can further drill down to analyze what actions we need to take from releasing this work order. So when we were looking at the block schedule, we were looking at based on the color coding of the campaign, similar characteristics of paper and how many jumbo rolls we are creating. Now let's look at the individual jumbo roll that are gonna come out of the shop floor line and how it is further getting used and consuming capacity at slitter and winder operation as well as sheeter operation. So the color coding helps us represent that here. And clicking on any one of it, we can get into the details of when we need to start, the process is going to end, what is the production input, which is nothing but the jumbo roll itself, and what output we're going to get is the slit rolls, details of slit rolls. On reviewing this, the planner can release, which will send this detail to the execution team as work order in manufacturing cloud from Oracle, which they can review along with the trim details that we saw earlier. And this is how we provide a comprehensive solution on how the jumbo roll needs to be cut with granular details of the knife changeover. While the knife is getting changed over from one particular cut to another, it also tries to minimize the knife position changes between the two knife changeover as well, and helps us truly optimize against demand lateness, reducing waste, trying to minimize the waste and the knife changeover that would be required. Considering additional factors like some customer orders cannot be fulfilled from edge and other things, which can be order specific constraints that can also be set up.